Hello. Welcome everybody to the Scott Science Scholar STEM Success Series. That's a lot of S's. We're glad to have you here. Today, it's my pleasure to introduce you to Dr. John Noto. Dr. Noto was a student here at Miracle College. He was one of my first thesis students and worked on a cloning project, actually cloning luciferase, and did some interesting stuff in my lab. And actually, I had a student yesterday who texted me a picture of a DNA gel that she had run showing successful PCR products, and she was using a program that was programmed into the thermocycler by Dr. Noto. So his legacy just lives on here at Miracle College. But I learned a lot about thesis advising Dr. Noto. And one of the things I learned is that students really can just take off with a research project. And that was definitely the case for Dr. Noto. I think he was great as a student and loved the classroom, but when he got in the lab, something transformed, and he was just really engaged in his research project, put a lot of work into it, and had some really great results. And so I think that inspired him maybe to go on and think about doing some other things. And so he's going to talk to you today, and rather than give you an abbreviated version of his life after Miracle College, he's going to do that as part of his talk. So we discussed it and decided that he'd tell you about those kinds of things. So this will be the extent of my introduction. What I will tell you is that he lives here locally, and I think if any of you have questions about finishing up here at Miracle College, or about your aspirations in science or STEM after graduate college, Dr. Noto is a great resource, and so I would definitely encourage you to talk to him.
To be an informal discussion, and should I speak into the microphone, or can everybody hear me all right? Everybody's good? So I like to have my classroom, as you can see here, I'm a professor of biology right now. My classroom, I like to have it be a more informal setting where students are liberated and we can have a discussion. So if at any point during my talk, if you would like to stop me and have me elaborate or clarify on something, or even just offer your opinion on something, I'd love to have that included as well. We'd love to hear your voice. This talk is to help you all and be practical for you all. So it's to grad or not to grad. Do you want to go to grad school? Do you not? How do you make that decision? And how can you navigate a successful career in science? And that's kind of the theme of this talk. So Dr. Gibson, thank you for that wonderful introduction, but I thought it might be useful for you all to know not just what I do now, which is I teach anatomy and physiology at Roane State Community College, but to see what the ladder of events were that brought me there. So I started just like you all at Miracle College, and my degree was in biochemistry. So how I arrived at biochemistry is through my own personal interest. You all get to choose your interest or choose your direction of your education. That's one of the really amazing things about being a college student. So I was interested in biochemistry because I thought I might apply that knowledge to a job someday. I thought I might like to be a doctor, a physician, something along those lines. After getting that research experience in college, I decided to seek out new research experiences because I thought I might like to go to graduate school. I wasn't quite sure, so I really wanted to get my hands dirty, and I did that at Emory University in Atlanta, and acted as a research associate for a few years. So that's a fancy word for a lab technician. I didn't have a lot of autonomy. I was granted the ability to perform research though, and that was my goal there. And so that experience solidified my desire to become a professional researcher, or to earn my Ph.D. in genetics and molecular biology, which I did at University of North Carolina. And I followed that up with a postdoc here at the University of Tennessee. and transferred that into now my current position, which is assistant professor of biology. So I've talked about, introduced the concept here is how you can succeed in a career in science, but there are many different definitions of success. And what I would say that most people would think a successful scientist would have, what is the goal? You might think about making impactful contributions to your field. And so the way that you do that is through publication. You do the science, you make your hypothesis and test it and publish those results. And so publication is definitely one measure of success for a scientist. Those publications can earn you recognition from your peers, which is, something that you might even get in college. Get a little taste of that. So recognition is very important. You want to have positive feedback. Also, a lot of scientists have fancy job titles and are well compensated. So your job status and your salary, those are other ways that you could define success. Now, all of these things are nice to have, but I would say that no one of these is going to be truly the motivating factor for someone going into science. And I think that when you're choosing a career, the best way to approach it is not to say what are the accolades or the salary that I want, but I think that at least for me, it was finding a balance between my goals personally, my goals in terms of my family life as well included in that, and balancing those with my professional goals and interests, which include things like earning acclaim or doing interesting research, getting publications, but also finding a good intersection of my skills and experience and also connections that open up some of those doors for you. So to find a career that fits, at least for me, I tried to find one that could balance all three of these. And so, of course, you can also change some of these. These are going to change over time. Right now, you're probably going to put a lot more weight into that top bubble, what your professional goals and interests are. So, what do I want my salary to be? Do I want my job to be interesting? But as you get a little bit older, you might start thinking a little bit more about this family planning and how you need to balance those goals with your professional goals. So if you're thinking about a career in science, you should know what a scientist does. And there's a lot of definitions of a scientist. But I think a common one is a person who conducts research to advance knowledge in your field. To take that a little bit deeper, you conduct research by forming a hypothesis and accumulating data that's through experimentation that's going to either disprove or prove or help to prove that what you're saying is accurate. And that's going to advance human knowledge in that way. If you're interested in picking up some literature that might be inspiring, I highly recommend looking into Edward O. Wilson. He's a renowned scientist that's written a lot. And he has a lot of really, I think, interesting things to say about the field in general and how it's important. Different things you can consider as a young scientist. But his definition is that he or she has shown that ... You can complete that sentence with something. You have shown that something is true or not true. And I like that definition of a scientist. Well, what do scientists do in your day-to-day practice? There's lots of different things. You're going to be multitasking a lot of science. A lot of times you're going to be critical thinking. That's what we associate scientists with. But scientists also have to communicate their research and communicate in a classroom setting or in research conferences or even coming back to your alma mater. A researcher, a good one, is also going to be a student. You're constantly taking in new information and using that to change your opinion or to entrench your position, as may be the case. But I think probably the best definition of a scientist that you're going to be using most in practice is being a problem solver. And so I like to think about careers in terms of what benefits they offer. Lots of careers are problem-solving careers. And you can think about problems and how we deal with those as being a measure of how painful a problem is over time. So what do I mean by this? Some problems are constant. They provide a constant source of pain for society or for a person in general. So one example of a problem is social inequality. There's some pain that this causes society over time, and the people that deal with problems like these maybe be like politicians. Other problems, the pain of that problem is going to increase over time if that problem's not dealt with. And so people that deal with these sorts of problems are often in the engineering sector. Problems that they deal with, sagging infrastructure, maybe, the longer that they go on I-40 without repaving it, the more potholes there are and the more cars get damaged. So engineers deal with problems that are steadily increasing in their severity. Other problems is more of a, logarithmic or exponentially increasing pain over time. So these kind of examples would be maybe war or physical trauma, and professions that deal with these type of problems might be physicians or soldiers. Entrepreneurs are going to have maybe society has a little bit of pain, maybe more like an itch, that an entrepreneur is providing a product that satisfies that itch over time. Now, scientists often are addressing maybe a problem that hasn't even revealed itself yet as a problem to the world in general. So maybe we're right here, and some distant date off in the future, there's going to be a problem that we have to deal with as a society. And basic research allows us to, start working on the solution to the problem before the problem even emerges. Can anybody think of an example of a problem that society is facing or has faced where it doesn't become evident until maybe later on in the future? So where something just comes out of nowhere and hits you, it's a big problem. COVID-19, yeah. So that's exactly the idea that I had. March 2020, we had this big problem emerge. Now, does anybody know, or does anybody know of any of the solutions that have helped us to manage that problem? We're all in person right now, by the grace of God and because of science. But what were the scientific solutions to this problem that allow us to now be sitting less than 6 feet apart from one another? Masking, yeah. The science of wearing masks. Vaccines are a big one. Vaccines have been around for a long time. Why were we able to deal with this one so rapidly? I believe Dr. Brigatti gave a talk on this pretty recently that I heard was very enlightening. In the 60s, scientific discoveries were being made all the time. There was lots of low-hanging fruit in the world of science, discovering what the genetic material was, or different things inside of our cells that are going on. And messenger RNA was discovered in 1961, which basically gives us the code to make proteins in our bodies. Now, later on, 30 years later, people started to speculate that maybe there are applications of our understanding of messenger RNA could be used to do something useful. Besides just knowing what's going on inside of our cells, we might be able to use this to induce immunity. The most common method for vaccination was using a dead or dying or kind of weak version of some pathogen and putting that in your body so that your immune system is able to fight that off in the future when it encounters the real pathogen. Well, it was speculated that maybe instead of putting a dead virus into your body, we could just put the proteins that make up that virus into your body. and use messenger RNA to deliver it. So, fast forward 20 years later in 2012, those sorts of mRNA vaccines went into clinical trials. And so by the time COVID-19 emerged in 2020, we had, decades and decades of research that had already built, a path to a solution that allowed us to rapidly deal with this issue. Wherein, if it happened in the 60s, or as it happened with the Spanish flu, it was a worldwide issue that killed millions and millions of people, more than it should have. So scientists are going to be scientists and basic scientists are kind of an insurance policy against problems that have yet to even emerge. And a less kind of dismal way to put it, instead of pain over time, you could also think of this chart as showing what the value of the solution is over time. I like that. Maybe I'll change that for the next time I give this presentation. So, why become a scientist? Well, there's many different reasons. You had fun doing your senior thesis and you want to explore that a little bit more. Maybe that's one. So satisfying your intellectual curiosity is definitely a reason people get into science. I'd say most people do it definitely not for a paycheck, but to make a difference in society. You want to make your contribution. Think about, when you're on your deathbed looking back at your life, you want to say, I've done something for good. At least that was one of the ingredients for me choosing science. It's also challenging and rewarding when you overcome a challenge. So in science, you're going to be challenged in many different ways over the course of your career, and overcoming those challenges is very empowering. Having an advanced degree in science will increase your earning potential, but I wouldn't say that that's the key motivating factor for most scientists. Job security, that's a big one that I don't think gets talked about very often, but performing science is difficult to automate. There are experiments that robots run right now. I had some experience working with people developing that in the lab at UT actually. And what I'll say is it's a long way from replacing people in the lab. Robots are not going to replace scientists anytime soon. You need a brain to think critically at this point. And then finally, the desire to teach, to share the information that you've learned with others, whether that's presenting at a research conference or whether you want to make that your career permanently. That's a good reason to become a scientist. So where might you end up if you do decide to become a scientist? Most of us will end up in academia, which means you work in a university or a college, some academic setting where the goal is to advance knowledge and to teach that knowledge. A lot, increasingly, I think, industrial science is becoming more of a thing. And so a lot of scientists choose industry. The pay can be better, but there's also issues maybe with job security. Some of those industries are a little flimsier. Industry is another major avenue, though, for scientists pursuing careers. And government, nonprofit, there are other settings too that are kind of non-traditional settings. People can help to consult and inform policy if you have scientific understanding. You can also work in a nonprofit setting like, St. Jude's, for example, is a research organization that's not tied explicitly to a university. But the goal is still to do research and to make a difference. So some of the titles, I won't stay on this slide too long because it's a lot of reading, but if you're interested in learning more about job titles in these different settings, I have here shown. If you're going to be a scientist and go on to pursue an advanced degree, I would expect you're going to definitely spend a lot of time in academia. Now, another important piece to the puzzle, I would say, is thinking about your job prospects. And one of the important things to think about is, where do scientists work? So outside of just the general settings, whether you're going to be in academia or not, it's important to think about where jobs are available. So just a quick Indeed.com search for Knoxville, Tennessee. There are 337 jobs currently listed. Do you think that's a lot? So if you go down to UT right now and see how many biology majors there are at UT, I bet there's more than 337 of them, and including the biology majors here. So that pie of science here in Knoxville, and this is not a thorough job search here. This doesn't include Oak Ridge, where the National Laboratory is. There's lots of stuff kind of maybe on the periphery of that job search that I did. But Knoxville is definitely, I wouldn't say it's a bad place to be a scientist, but it's not a hub of research in the same way that some of these other places maybe are. So if you are certain that you want to stay in this area, for example, I would be thinking more about what are the jobs that I'm working towards that are specifically available for this area. One of the really great things about becoming a scientist, going to graduate school, I think, is that it's kind of an adventure. And so I welcomed the change in scenery as I went around. And I ended up back here, though. So maybe I should have looked a little bit at the job availabilities and done some planning in that regard. But so if you just do that same search for science in the nationwide Indeed.com search, you'll see, some of the big cities. And these big cities have big universities. And those universities attract, the economic producers that are going to hire the people that graduate from those universities. So if you go where there are universities, typically there are going to be jobs for scientists. One of the great things about where you are right now in your education is that you get to follow your interests. Not only do you get electives, I took tile making in class because I thought it would be cool to make tiles, but I also thought it would be cool to study biochemistry. And having that choice, being able to direct my efforts at a subject that I find personally interesting, that is a huge advantage to being a scientist. So some really amazing stuff going on in the field of scientists. You had in the field of science, you have the James Webb Telescope that's just been launched, looking for life elsewhere in the universe. You have particle physicists and things like that, untangling the mysteries of quantum physics. People are, if you're at all familiar with what's going on in quantum physics right now, it's mind-blowing stuff and could hopefully provide limitless energy for our progression as a society. And I personally chose the field of biology. So my interests, I began exploring these, as Dr. Gibson mentioned, here at Marable, my senior thesis research project, which what I basically did was I took cells in a petri dish, and with a construct, a DNA construct that I built in the lab, I was able to, sort of modify the genetics of this organism and allow them to make a protein of my choosing, a protein called luciferase. And this is, in effect, the way that mRNA vaccines work. You have a gene that you want to appear, or a protein you want to appear in an organism. And so my protein of choice was luciferase, which makes things glow. And this was an enlightening and illuminating experience, pun intended there, but that I really helped me to gain traction in my overall education. I started thinking about my coursework in a different way once I started, getting experience in the lab. It seems very abstract when you are learning lessons in biology. You're talking about DNA and RNA and proteins, but when you start working with the material in the lab and seeing the effects of that work, it really starts to make sense and helped me a lot. to progress as a student. Other things that I really loved about the senior thesis research project, your time in the lab is unstructured, which it can be a good and bad thing. If you're short on time, being a scientist is really difficult. If you have a party you want to go to, you have to go finish your cloning, you have to make difficult choices. But I was able to play in the lab, and that was really a fun thing to me and something that I wanted to get more experience doing. It also allowed me to control the direction of the research. If I had a failure, I didn't have to just keep failing. I could choose to try something different and even pick the subject, pick the sorts of experiments that I wanted to do. So I hope that you will all take this really amazing benefit and take the bull by the horns, because not all schools require a senior thesis research project, but it can be hugely beneficial. So once you've done your experience at Marable College, it's over, you could even start planning now, but choosing to attend graduate school, I think, is best a decision that you need to put a lot of thought into, talk to your mentors about, and don't make it a decision where you're choosing a path of least resistance. You know, I'm expected to go to graduate school, so I'm going to do that. Or I think I can get into graduate school, so I'll do that. And I think the only way to make certain that you are making an intentional decision is to have experience doing what you want to do and talk to those who do what you want to do until you kind of convince yourself, this is what I want to do. I earned a Ph.D., so this is the graduate degree that I'll kind of frame this conversation in, but a lot of these same concepts apply to choosing a master's program. What is a Ph.D.? It's kind of hard to summarize in just a sentence or two what earning a Ph.D. is, but you can do it visually. So here in this circle, imagine that this represents the totality of human knowledge. All human knowledge is in this circle. Well, when you start learning, say elementary school, you learn a tiny bit of that circle of knowledge. And you learn about a lot of different subjects. In high school, you learn a little bit more about those subjects. And then in college, you learn a little bit more about a lot of subjects, especially here at this liberal arts institution. You get that holistic learning that I think is very important. But you also begin to specialize. You point at a specific area of interest. In an advanced degree, what you're going to do is keep doing that. You stop focusing on the whole and kind of zoom in on what your particular research focus is going to be. So this would be maybe a master's degree. And in a PhD, now what you're learning is going to start pushing up against the boundaries of what human knowledge is. The goal of a PhD, if we zoom in on that boundary, is to make just a slight little push. You know, when I published my 4 papers or whatever it was in graduate school, my contribution to the totality of human knowledge is very tiny. But to me, this was my world. I live in that tiny little bubble. And so that's what earning a PhD is. You live in a tiny sphere within the whole of human knowledge, and you're trying to push that boundary as far as you can, which ultimately is usually going to end up being a very small push. But it's also important to put that back into the perspective of the whole. Now, if you're thinking about master's versus doctorate, there's a few different ideas that you might consider, which are, what are the prerequisites? You got to complete your bachelor's degree before you move on to do this advanced degree. Here for a doctorate, it sometimes helps to have a master's if you want to pursue a doctorate, but it's not an absolute requirement. And master's degrees are going to typically be shorter and have fewer requirements in terms of making a thesis or dissertation, things like that. So time to completion, you can expect a master's degree to take 2 or so years and doctoral 4 or 5 years, but there's a spectrum. Not everyone finishes at the same time, and some people work on a master's degree while they have another career going, and so it might take significantly longer. Just the raw number of degree holders, I'd say maybe 1 in 10 people in the United States has one of these advanced degrees, so there's a lot of us out there. And there's the main differences, I would say, between earning a master's and a PhD is that for a master's, you're gonna be thinking more about the direct applications and spending less time, becoming this broad expert, but you want to gain deep and industry-specific knowledge that's going to be really useful and applicable. Whereas the expertise for a doctoral degree is used to contribute that original knowledge to the field and not necessarily to provide a direct application. So going back to that basic research provides an insurance policy for future problems idea, your contribution to science may not have a direct application. I know that mine haven't so far, other than we've discovered new classes of RNA, for example. In terms of what doors these types of degrees might open for you, many management positions, leadership positions in companies will require an advanced degree, master's, and a PhD is really going to be useful if you want to work in a college or university setting. But nowadays, there are actually a lot of industries that require PhDs as well. So once you have made this decision, I want to go to grad school, I want to further explore this path that I'm on, how do you choose which grad school to go to? Well, the way that I did it was first by looking at rankings of those grad schools. So that may have been the same process you used to choose Maryville College, for instance, which you can find in the U.S. News rankings usually. And right now, if you look up the rankings on U.S. News for graduate schools, a lot of them are going to be peer rankings. They don't use maybe absolute measures like endowment or diversity or employment outcomes to rank these grad schools. They send out surveys to people with PhDs and say, rank these in order. And as far as I know, that's the current US News system of ranking, which I think is pretty effective. I think if you have a PhD, you probably have some understanding of what the quality of certain universities are. You also, when you're choosing a graduate school, you'll want to make sure that their research focuses align with your goals. So if you're interested in plant biology, for example, here at University of Tennessee, there's lots of plant biologists there. Whereas if you're talking about just raw, pure molecular biology, or RNA biology, which was that tiny little bubble that I lived in as a graduate student, there's not as much for you there. So if you know what it is that you want to do, what field of research you want, it's worth looking into what fields of research certain universities really specialize in. Also, the application fee. If there's no application fee for the school, why not? Go ahead and apply. But if there is, that might be another consideration. Sometimes those can be hundreds of dollars, so that can limit the places that the pool that you choose from. And then finally, location. I ended up at the University of North Carolina, and primarily I wanted to stay in the Southeast. My family is here, and so I wanted to be nearby to my family, but also because I just love this area, and I feel good here. I didn't want to go to Wisconsin or Michigan and brave the cold. So like I said, how I chose my university that I ended up going to had a good reputation. My mentors recommended UNC Chapel Hill to me as a place that I should apply to, given those criteria that I was judging it on. I was interested in the research. And my mentors also knew people there. That was really important. But also the location, again, fit what I wanted. So once I was ready to apply to grad school, you have to figure out what are the qualifications that they're looking for. And certainly your grades are going to matter when it comes to whether or not you apply to certain PhD programs. If you look, they will tell you what the average accepted GPAs are, what the average accepted GRE scores are, the graduate requisite exam that you'll want to take before you apply. And also, you'll want to have relevant experience that bolsters your application. Your application is basically your argument that you should be offered an invitation to come in and do research there. So in order to make that argument, having good grades certainly helps. Having good GRE scores helps. But having relevant experience, I would say, is something that, there's no fudging that. You can't tell a story saying, I should go to grad school without saying, I've personally experienced doing research. Letters of recommendation can be very, very important. And so you're already making relationships with your mentors right now, and some of them might be writing you those letters later on. And so talking to your mentors candidly about what your goals are, and obviously performing well in their eyes is going to help to make that not just a recommendation letter, but a good recommendation letter. Having not just your application be convincing, but having someone in your corner who is an authority that says, this person is good at this. This person I think will succeed in grad school. So, if you're thinking about going to grad school, maybe start thinking about who your recommenders might be and talk to them about it. And then through all of your experience, you'll be able to write some sort of personal statement where you talk about what your interests are and what your goals are and how you intend to see those through and how earning a graduate degree plays into that. How's that going to benefit you? And then lastly, the interviews. Interviews are awesome. I interviewed at the University of Arizona, and I didn't really imagine that I would go there, but I applied anyways because who knows, I might not get into my top choice. But when you go on interviews, when you're offered an interview, typically, and I don't know that this holds true for masters, I only did PhD, but if you're offered an interview, there's a good chance they're going to offer you a spot in their program. And so knowing that allowed me to really go on the interviews and strip away my nervousness and allow me to really go and experience the place that you're going to be for the next 4 to 8 years potentially, or the rest of your life if you choose to stay there and work. So I would encourage you to also apply to places where you don't necessarily see yourself living, because you might get there and you might love it. I love Tucson, and I would have been happy to go there if I hadn't gotten into UNC Chapel Hill. And the process of interviewing is really fun. So once you've nailed the interview, you get accepted to grad school, how then do you become a good grad student? What does it take to succeed in grad school? And to be a scientist in general, you need passion. There's the reason that you're in science is because you're interested, you're passionate about it. But there's going to be hard times. You have to persevere and you have to be tenacious. You have to be diligent and power through those hard times because they do come. You also need cogency. You have to be able to articulate what you know and speak concisely, and also to be convincing. Sometimes people aren't going to take you at your word, and so to be a convincing speaker or a convincing writer is a very important quality in graduate students. And then finally, to succeed in grad school, you really have to have good mentorship. And I would love to talk to you about what it is to be a good mentor and how to seek out good mentorship. but I think I'm running up against my time. One of the potential pitfalls that you'll see in graduate school, and maybe you've even felt this a little bit in college. I came from a rural background. I was raised in Sweetwater, Tennessee, not a lot of scientists there, small town of about 10,000 people, more cows than people maybe. And doubting yourself is a natural thing in academics and in science. But remember, you were invited to this party. Once you've earned that acceptance into graduate school, you've been judged and you've been deemed worthy of being there. So it's natural to get down on yourself, but remind yourself also that you were invited, that you belong there, and that it shows because of that acceptance. You're gonna fail a lot. Some of you might have failed some in undergraduate already. And looking back on these failures that I had in my undergraduate research, it seems silly how small the issues were at the time. They seem huge when you're a student. But when you're in graduate school, your failures, you can fail over a course of years. You might have a line of research that you see through and it's a complete dead end. And so you can fail spectacularly and it can be really difficult to deal with. But that gets back to the perseverance. And if you have good mentors, they're not gonna let you fail so hard that that it negatively affects your career or your well-being. So how long does it take? It can take a long time to work through a PhD, and sometimes you feel like you've been that Zeus has condemned you to push this ball up a hill in perpetuity. But trust, you will reach the end of your PhD if you are tenacious. So how did my experience go? What was a general experience in graduate school earning a PhD? You start with rotation. This was a really exciting part of a PhD program where you look at all of the research at that institution and you pick a few labs that sound interesting. So I worked with one lab that used mouse as a model and did behavioral assays and also genetics to kind of figure out clues about the mechanisms of autism. I ended up not choosing that lab because working with mice was not my forte. I preferred fruit flies. But so you rotate through and try your hand at different forms of research. That was really fun. Eventually, if one of those labs likes you, they'll offer you a full-time position in that lab where now you can take that research and run with it and choose a project. The lab that I worked in was looking at a disease called spinal muscular atrophy, which arises due to a defect in RNA processing. But what spinal muscular atrophy is when muscle atrophies or dies as a result of dead motor neurons or loss of a connection between a neuron and muscle. And I used fruit flies, believe it or not, as our model because we don't use human beings in the lab that often. I did switch my project from looking at spinal muscular atrophy. So there was a discovery in the lab where someone saw some artifact on a gel and said, hey, that looks cool, I wonder what that is. And we actually discovered a new class of RNA in our lab derived from tRNA introns, if that makes any sense to you. But this RNA had lots of practical applications. Up here at the top left was my favorite. We had an idea that we could use circular RNA to sponge up or to soak up oncogenic microRNAs. What oncogenic means is that it causes cancer. So we had these molecules in our body that we know to cause cancer that we could theoretically sponge up using my circular RNAs. And so I found that project a lot more compelling than this other project that my boss had told me actually the cure for spinal muscular atrophy has already been made. We're more interested in the basic science of how defects in RNA processing can affect, how your neurons and muscles work. And I was also able to apply my research in circular RNA to brain development, which I found very interesting. So don't be afraid to abandon a project. Of course, you're going to want to do that in consultation with your advisor. But choosing a field of research is not a permanent thing. And my postdoctoral experience, I went away from flies and mammalian cell culture and brains altogether. I worked with plants, making chloroplast genomes. So once you have done all of the work, you're ready to publish your findings, you basically are judged again. And if you're lucky, those reviewers, the judges, the referees, your peers, the peer review process, they're going to look at your research and say, is it good enough or is it not good enough for this particular journal? So that's a very difficult time in your graduate career, but it's rewarding when you finally finish writing, which is a long process. You probably all have a lot of experience with this. And then finally, you're up and ready to defend your PhD and earn that PhD. You go up in front of another panel of judges, not this time from an academic journal, but these are your mentors, the people who have trained you. And you have to defend the validity of your work and why you deserve that PhD. So that can be scary. But eventually, you defend that thesis, you are successful, and like Michael Jordan was when he won his first NBA championship, you're exhausted, but just so thrilled to have that PhD and to finally be done with that process, right? Well, no. If you want to continue a science career, your work is going to be judged. But that's one of the good things about being in science is that you improve your methods over time, and that process becomes easier. So lastly, in graduate school, that was an experience I had that was very impactful for me, was trying out different things, not just rotating through different labs, but trying my hand at something that wasn't just pure research, and that was teaching. So that scientists are oftentimes going to have to be teachers in one way or another, but I wanted to try it in a real college setting. And so at UNC, I was lucky enough to get an internship while I was there that allowed me to go teach in a real college. And I enjoyed that experience more than the rigor of actually seeing through the whole process of research. And so that's what I've chosen to make my career out of. Another really important thing happened while I was in graduate school, and that's that my wife fell pregnant, and that really changed my career goals. And going back to that balance of personal goals, career goals, and your skills and experience, the personal and family goals, once we got that positive pregnancy test, changed a lot. And so my balance of work and life, which is something that's really important to have in undergrad and graduate school and in your ultimate profession, I had to figure out how to be a good father and a good husband and a good researcher and a good teacher all at once. And so it's definitely important that you keep in mind that there has to be balance in your life to be able to succeed as a scientist. And one of the great things about graduate school, one of the reasons I was so excited to do it, is that it's kind of a continuation of the undergrad experience. There's a lot of fun to be had in grad school. You end up making lots of friends. It's a very social time. You end up having a new family. Your lab becomes your family. You spend so much time with them that they seem like your real family. And so having others to rely on, to go through this hard process with, and to have fun with, to keep yourself sane is a very important piece to this puzzle of being successful. And just to talk about my real family, not just my lab family, here they are. My beautiful wife, who's actually a Maryville College graduate herself, and she works at ORNL. So that's how I came to be where I am. I had already wanted to transition into teaching during my graduate experience, but I've been able to do that since, and I'm so glad that I made that decision, and so glad that I've had the experiences that I have had. So with that, I'll thank you all for coming. Thank you guys for paying attention, and if you have any questions, I'd be happy to answer them.
Did you want to become like a professor from the beginning, or did you have other kind of goals before that?
So yes, I knew that I wanted to become a professor. Now, I wasn't sure if I wanted research to be primary or teaching. I admired my professors in college, and I really came to enjoy the experience of being a student. And I kind of intuited that I would also enjoy teaching. And so that was kind of always in the back of my head throughout the whole process. And so, when you're thinking about the particular degree that you're trying to attain, you definitely want to keep, all your options known to you. So I wasn't always certain that I wanted to be a researcher or a teacher because I didn't have that experience yet. But so once I did get that experience, I loved the research. I visited Dr. Gibson in the lab with a few students earlier, and I got wistful. I miss doing research now, and I'm trying to find ways to incorporate that back into my teaching currently. So funding is kind of an issue, as it is everywhere. But I love the act of research, but I also love teaching. So I did know that I wanted to be a professor. Did I know that I wanted to be a researcher or a teaching professor? No. If you want a Ph.D., most often the reason is because you want to be a professor of some sort. And teaching is often a duty of research professors, but a very minor one. Great question. And I also knew that those skills that I was gaining during the earning of my PhD could also translate to industry. And so that is something that I never really explored. But if I had an unlimited amount of time on this earth, I would definitely try out industry too. But I found something that I love and that works for me. And so that's why I am where I am today. Yes?
When we were talking earlier today, you mentioned being aware of some labs that maybe have toxic environments, or maybe sometimes put students or postdocs in impossible positions by assigning them projects and just expecting them to pull things out of the hat. Can you give some advice to students about how they might look for danger signs in
Yes.
selecting labs or programs?
Yes. So in selecting your mentors, here at Maryville College, you're assigned an advisor, right? And you all are fortunate that your advisors have been thoroughly vetted. They are great mentors. And in graduate school, the reason that a lot of those professors are there is because they're there to do research. They're there to get their job done and satisfy their own goals, and not necessarily to, give you a path to success. That's an ideal situation, but a lot of labs can kind of chew people up and spit them out. So before you join a lab, I would say even before you choose a lab to rotate in, if you end up doing a PhD, is to find former members of that lab if you can, or current members of that lab, and check their pulse. Talk to them about the pros and cons of the field of research that they're in, but also the mentorship style of the boss of that lab, what's called the PI, primary investigator, and see if you can glean information about what life in that lab is like, if it's going to be a good environment for you. Because I guarantee you, former members of the lab are going to have a lot to say. You spend 6 years with a mentor, and there will always be good and bad. I butted heads with my mentor in graduate school, but in a good way. It was a healthy relationship that we had, and any of his former students they did have that to say about him, is that he's looking out for your personal interest. And so when I said I did a teaching internship, do you think that that most PIs are going to be glad to lose their students to teaching for 10 or 20 hours a week? No, they want you in the lab doing research that'll be published with their name on it. But my boss encouraged me to seek out that opportunity and to take time out of the lab. And so, definitely do your due diligence, not just on the field of research, but think about what sort of mentorship strategy you need, and if that lab environment is going to fulfill that. So talk to people, because people will talk to you. And that's another thing that I would say is, if you think someone has an experience that might be, they might be able to give you advice, anyone that you ask in academia or anyone who has one of these advanced degrees would, I'm sure, take it upon themselves to give you that advice, to take time out, because we've all benefited from mentorship, and now the torch has been passed. We're ready to be mentors, and so if you reach out to anyone that has that degree, I'm sure they'd be glad to help you make those decisions.
Other questions? I'm sure that Dr. Noto would be happy to answer questions if